DRBFM structure, we have GD cube, which relates to good design, good discussion, and good design review. So when you have a good design, good discussion, and a good review, then you can find the problem. So you can say that GD cube is a collaborative approach toward the design process and identifying the problems. Then you develop a sustainable and robust solution for your problem. So if we have well-designed systems, then the problem always happen when the change happen. Either this change is expected or unexpected, which we call here intentional or incidental. So this concept of GD cube help us identify the changes that we did. So if you have a good design, we have a concept saying that don't change a good or robust design as long as it's working. Don't fix it until it's broken. Sometimes you need, as we discussed before, you need to do the change. It's a must. The market is demanding that change, and you need to move forward with the new features in your product or a new systems to be implemented in your machine or in your vehicle. So change is a must in many cases. So when you have a good discussion, then usually you involve others who are having expertise in that field. Then you discover the potential problem, and you find any hidden problems by taking those advices from those experienced teams. So if you have a good design review, then you study the changes to identify and eliminate any potential failure. DRBFM as well relies on something called MB, related to the word Maizenbushi, which is a Japanese word, relies to or refers to the mindset of proactively and predictively addressing all the direct and indirect potential aspects of the problem so that you'll prevent the failure. And that we call it proactive problem prevention. In other words, it is a kind of a preventive maintenance. You are studying all the tools in front of you, all the data that you collected, all the expectations that you had from the experts, in order to predict how this system work. Let's say you are designing a computer, and this computer have a certain CPU, certain hard disk, certain RAM. Based on that, you say this computer is going to handle that specific software by studying the properties of the software, studying the performance of the laptop or of a computer, and so on. So that's called proactive problem prevention. So you are preventing the problem from happening while you're studying that system. So if you want to look at the proactive prevention cycle, so firstly you start with the recurrence prevention. So that's related to the system and management. Then you will go to the proactive prevention for the new problems. Now you're having planning, design, evaluation, then pre-production evaluation. This helps you predict and avoid any unseen problem. Then you will go eventually to the mass production to produce the product. And you go back to the cycle of quick solving of actual problems. So if there's any problems occurs along the way, either pre-production or after production, then you want to do a proactive prevention cycle, which means you're always looking at the process and trying to maintain it as moving forward. So you look at the investigation of the present state, what's going on. Then you study the cause and the factor analysis. Then you do counter measurement, which is implementation and verification that the problem is really being solved, and so on. So the cycle continues. Then whatever you learn in releasing the current product, you apply it on the future products. So if we look at the fundamentals of the proactive prevention process, so you have firstly the early discovery of issues using the concept of GD cube principles. So you go from GD cube to improve design. So you are having changes along the way. So if you're going from GD Cube all the way to improved design, to reach here, you pass through, you want to verify it's a good design, you want to verify it's a good design review, and you're having good discussions with the experts. So in good design, you minimize the changes, you just do the changes that you need, then you make a problem visualization. Whatever the problem is, which part you're having problem with, just be specific in your problem, identify it, and if there's any visual representation of that problem, show it up and look at the details of that specific defected parts, let's say, or that specific problem. Then you go to good design review. Maybe before we do that, maybe we can look, okay, we have a certain problem in order to reach that design and in order to deliver that change. Then you take discussion with the experts and you uncover any hidden problems that may show up again along the way, and in a concept of problem discovery. Then you move to good design review, you identify countermeasures and you make sure the problem have been solved, and eventually you land to your improved design with as minimum problems as possible. Now, if we talk about the approach to quality, as we said, Toyota is delivering quality products by applying DRBFM concepts and the related details DRBFM, like the GD Cube. So Toyota approach for quality, firstly they say quality is first, which means they care about safety, durability of the product, and the reliability through a set of tests and certain procedures they follow in documenting the development of products and delivering the change. Then they are making sure the highest quality is happening at affordable price, which happens by minimizing the unneeded changes. You just do the changes that really needed and requested by the customers. Then they put customers first, not only as a word, we hear that word everywhere, but you make sure the customer is happy and satisfied with the product, and listen from the customer and see what you can do to develop and to improve the products in the future. Of course, if you have a quality product, customer complaints will be at minimum. For the proactive prevention cycle, again, in a different form. So you start with advanced quality prevention. So you stop the problem from happening. You're trying to predict what could happen if we do the design this way or we do the change that way. So you are trying to predict the problem and avoid it. Then you go to outflow prevention. So you stop the problem before it reaches to the customer. Like if the problem is still in the factory, still in the engineering department, then you can still solve it. Then you go thirdly to the early detection and early resolution. So you minimize the problem and you solve the problem quickly. And of course, you want to avoid that problem from happening again from using the recurrence prevention. So you make sure you don't experience the same problem again, and you write your lessons learned and the experience that you gathered through that process of solving a certain problem. Then you apply it all over your products and make sure that that kind of problem is not repeated again.